Okay, welcome back. We're on page 276 talking about the types of cloud computing. And we talked about infrastructure, which basically is just bare metal. You get to do everything. The next one's called platform as a service. And this is a little bit harder to describe, but basically what happens is they'll provide like an operating system for you, and all you do is just pick and choose like a line of business kind of a thing. You know, they're called containers. But you take the container and you install it on there, and it automatically, sets up configure. I don't know, maybe like you wanted to use Microsoft Excel, and so you put Microsoft Excel on there. So when you go there to use Microsoft Excel, in that case, you're actually only running the application. Okay. So if you said, "Well, I'd like to reboot my server," they go, "It's not your server. All you have is Microsoft Excel. That's the only thing that belongs to you. The rest of this stuff belongs to somebody else." See the difference? Okay, good. The next one is software as a service, where you don't install anything at all. For example, a classic example of that in the Azure world is I create a database. So I'm not installing Microsoft SQL Server. I'm just saying this thing exists, and therefore all I do is just add data. Right? I don't install anything. I just say I'd like a database, and it goes, okay, here's the database. Have fun. Cool. Okay, so there's a table that kind of sort of goes through this in some detail, and this one might be a good one. Infrastructure, platform, and software. Oh, I didn't talk about the software one. Sorry. So the software one, software as a service, basically is like hosting a web service. I have a couple of websites, and all I do is just pull my files across. I don't do anything. I can't reboot their server. I can't do anything like that, right? Okay. So it's kind of sort of similar to platform, but it's more like just the software. So software would be like the SQL Server thing or web hosting. Okay, cool. Anyway, lots of good information here on this little guy, this table 9.3. Okay. On page 276, they talk about regions and availability zones. With Azure, whenever I create a database, a website, or a virtual machine, whatever, it automatically puts them in 2 locations, and it puts them further enough apart so that if one data center got whacked, I don't lose everything. So it automatically duplicates. I don't have to ask for it. It just says, hey, what region are you in? And typically I pick the region that's closest to me because I assume that means I have the fastest connection. Kind of make sense? Okay. Virtual private server. So we've talked about that before. That's what I have here. So what I have here is I have a virtual private server. This is just like VirtualBox, except VirtualBox in the sky. That means I could go anywhere there's a web browser and click on this guy and log into this guy. Okay? Actually, don't even need a web browser. I just need to, I need some way to get to this guy, and then from there I can, start and stop the machine and do things like that. Anyway, that's how I use Azure. Now I'm going to skip a whole bunch of stuff and talk about costs. So let's just look at this guy. So right now I have a Windows Server 2012 R2 system. Its location currently is South Central U.S., and I get to choose that, and it's using Windows. It's using the standard DS1, which currently has 1 virtual CPU and 3.5 gig of memory. And then there's some other things you can do. So what I'm going to do is I'm going to pretend like we're going to create another one just to show you the kinds of things that you can get to. So I'm going to go back to Home, and I'm going to say Create a Resource, and I'm going to say, let's just pretend like I'm doing one of these. It's going to come up and say, okay, so, what's your account, and, what's your machine name, and let's just skip through. What type of disks do you want? I could have standard hard drives or premium solid state drives, and what kind of networking do I want, and what kind of remote management do I want, and all sorts of other things, blah, 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 blah. When we get down to the bottom, it's going to tell me how much it's going to cost. It's going to cost me 6 cents an hour to operate this guy. Okay. So I can go in and say, whoa, 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 I don't want this thing called DS1. I wanted something better than that. So let's find the one. Let's just change the size and see what the choices are. Well, I've got all sorts of choices. You know, size small and so I don't know. I want to pick this one, which is general purpose, 4 gig of RAM, 4 disks. The network is robust, and I got temporary storage and okay. Not actually going to do that, but the point is, I get to pick what types of things, and every time I pick something bigger, it's going to cost me more, right? Makes sense. Okay, so the CPU, price per hour. The network could be a price per gigabyte per second. The storage could be just how many gigabytes you've got. A pay-as-you-go kind of a scenario. I presume you guys are aware that students get a $100 credit on Azure. You could be doing the same thing I'm doing, walking in there and doing something. Now, plus you get 750 hours of a VM. Kind of cool. And then when you run out, like, you know, you have free services, when it run out, they just turn it off. And then you give money or not. And so it's no harm to try this. I mean, right? It's just kind of cool. Anyway, so that's how you would do this scalability. Now, the holy grail of elastic scalability is to take this concept and automate it. Let's say, for example, you're Netflix and you've got servers scattered all over the U.S., and then there's a brand new service that popped up, and so there's a spike in activity temporarily, you know, like for a week. Well, wouldn't it be kind of cool if you set up like little thresholds, like so whenever the CPU got to 80%, go ahead and add a couple more virtual CPUs, and whenever the memory got consumed, and add a couple more gigabits of memory, or when the network got consumed, you know, crank it up. And wouldn't it be kind of cool if you could do this automatically? So it automatically floats. In other words, the number of CPUs and the number of disks and the amount of RAM just kind of floats up when there's high load, and then it floats back down automatically. Wouldn't that be kind of cool? Okay, that's kind of the holy grail for doing it. Now, there are some add-on packages to the common services that actually will help you do that. Okay. All right. So that, believe it or not, is the end of Chapter 9. Now we're ready to move on to Chapter 10, which is logging. So first, I have to show you the Ren and Stimpy song.
What rolls downstairs, the owner and pears, rolls over your neighbor's dog. What's great for a snack, it fits on your back. It's long, long, long. It's long, long. It's big, it's heavy, it's wood. It's long, long. It's better than bad, it's good.
Okay, it's better than bad, it's good. Okay, so the introduction on Chapter 10 talks about, you know, the kernel and a bunch of apps are constantly generating stuff, artifacts, and data. And basically that data is really only valuable if it's kind of up to date, right? You don't really care about something that happened, you know, weeks ago. So how do you manage and sort and search the logs that are in the Linux system? I mean, you do have a finite amount of disk space. I mean, I can't just record everything and just let it run forever. That's kind of dumb. So let's talk about the types of things that typically would generate logs, log messages. So typically a log would be a text-based something saying like, hey, you're running out of disk space. Okay, that'd be a message. It probably will contain like the process ID that generated it, you know, and perhaps the user ID of who's actually running it. That would be kind of cool. So that's typically what a log would contain. Now, how do we manage logs? Well, the problem here is if I was to have logs in each individual machine, that would work. But again, if I want to search for something that's going on, let's say, for example, I want to find out the number of times we had unsuccessful login attempts on a computer. Okay? That would probably be an indication that somebody's trying to break in, wouldn't you think? Okay. So one option is I go to each one of my 100 machines and I look at the logs. Really? Or you would have something called centralized log management, where the system would automatically know that recording the log here, I also need to record it at some centralized point. So all 100 of my machines are all reporting their logs to a specific server, and I just search that one server and I'm done. That makes a heck of a lot more sense, doesn't it? Okay, just saying. And then I need some sort of an interface for doing queries and filtering, right? I don't want to be just throwing a bunch of text files and have to deal with it. And I want to manage like the retention and expiration rules. Like this particular log I want to keep for 60 days, and this one I want to keep for 30 days, and that kind of stuff. And mechanically behind the scenes, it may actually be broken up in like log 1, 2, 3, 4, 5, 6, 7, something like that. But when I look at it, I just want to see one thing. I don't want to be able to see individual files. Okay? Kind of makes sense? All right. So historically, what happens is we had syslog. So syslog is the old system. Syslog basically collected log files. The problem is Linux is kind of the wild, wild west. And, you weren't obligated. If you wrote an application for Linux, it wasn't like there was the Linux police that went around and said, you got to make dang sure you're using syslog capability here. You could basically do your own, which is not necessarily good. So apps are free to bypass using the old log system. So to make it easier, now we have a thing called the systemd journal. Systemd is just that's not what you type on the command line. It's just systemd is just the term we use for this overarching thing that we were talking about that does the booting and all the rest of that kind of thing. So systemd. So systemd journal. And there's the exhibit on page 296 that basically shows that. So let's talk about where the heck the logs are. Oh man, I closed that guy. Okay. Here are some of the applications and some of the things about what's happening. So for example, if I have the Apache web server installed, here's the program. And here's like where it gets stored. It gets stored in a configuration file. And the frequency is daily, and the system that it does is Debian. And then this is just kind of a listing of some of the places where you could get logs. Okay, kind of sort of makes sense. Okay, so where is the log? Who created the log? What's the log file specification? What's the frequency of cleanup? What system uses that log, and what's the description of that log? That's kind of sort of what this table is designed to kind of sort of show. It's not complete by any stretch of the imagination, but it basically says those are the kinds of things that happen. Now, the format for the logs. Most logs are text-based, but if it's kind of a security-related thing, like a login attempt, it's probably not going to be text-based. It's going to be binary. Now, there's an awful lot of advantages to having things be binary. First of all, they're smaller, typically, when that happens. You end up with something that's a bit tinier. So I'm going to just look at this. Okay, there's a log called a wtemp file. And the wtemp file is the one who maintains the login and log out information. That'd be kind of useful and be a little scary, too. So we're going to find that particular log and we're going to look at it, okay? But we're coming up on the 15-minute mark, so let's just do that in just a few.